Good morning. Hi, everybody. Thank you so much for joining us for this installment of our Steel Connect Classroom webinar series. We launched this series to help train and educate personnel on the plant floor, distributors, equipment manufacturers, really anyone involved in the plant operations. This monthly webinar series focuses on reliability, maintenance, and of course, proper sealing techniques. We will invite experts from across the industry to join us each month to help ensure that all personnel have the skills they need for success. My name is Anna Claire Howard. I'm the content strategist here at SEPCO. Full disclosure, I do work from home and I'm a mom. I have a toddler, so hopefully he won't make an unexpected guest appearance, but that's just the chance we take with working from home. So please bear with me. Today we have Chuck Tanner with us. He's the Director of Market Development for SEPCO and has more than 30 years of experience in the pulp and paper industry. 29 of those have been spent with SEPCO. So Chuck, while we wait for people to sign in, what's one of the more unique reliability situations you've witnessed on the job, or maybe lack of reliability?
One of the real big problems that you see in the field today is the topic we're going to discuss today is the importance and the maintenance of environmental control and flush water for packing services. Most plants tend to use way too much flush water, and most of them do not control the pressures involved in to maintain good reliability in packed applications by misapplying flush water.
Gotcha. Well, I'm looking forward to us diving into that a little bit deeper with today's presentation. Before we get started, just wanted to go over some housekeeping notes. If anyone who's interested can ask Chuck questions directly in the Q&A section. We'll do our best to answer those, in a timely manner if they're pertinent. If not, we'll answer them at the end of the webinar. There's also some documents and handouts you can download, including today's presentation and an infographic. This webinar is being recorded, and you will be emailed a link to it within 24 hours of it concluding. It will also be available on our website, sepco.com/community, as well as our YouTube channel. And the slides will be emailed with the recording. Okay, Chuck, well, I'm gonna hop off, but please take it away.
Okay, thanks, Anna Claire. Today we'd like to talk about some various things. Some of the things we're going to have to address briefly is what is compression packing and where it's located in the pump, and stuffing box reliability and why stuffing boxes require proper cooling and cleaning to operate efficiency, and how to set your environmental controls up to properly maintain and control your flush water usage. The flush water, the proper application of flush water is probably one of the most critical things as far as getting good, reliable packing life. Some things need flush water, some things don't, and we'll address that as we go through this discussion today. But the flush water is a critical lifeline to make sure that your packing is going to be cared for properly. There's just no substitute in some applications for proper flush water. Now, we're not talking about large volumes of water. We're going to talk today about controlling the use of that water, what's a proper usage rates of that water, and because there's a lot of misconception about flush water and how much is used, and just when we talk about the use of flush water with braided packing, it's very similar to mechanical seal. It's not totally leak-free like a mechanical seal is supposed to be, but flush water and packing is very similar, and you manage it very similar, just like you do with a mechanical seal. One of the things that we're going to be doing today during this process is that there'll be a series of polls and some questions that we'd like for y'all to answer. This first one is, what is the most critical environmental factors to monitor as far as packing in your pump system? If y'all would just kind of pick some of those choices there and let Anna Claire, she'll look at those, and we'll talk about some of y'all's results as we go through this.
Yep, we're just going to give everybody a minute to put in their answers. And now I'm going to close it out.
close it out. Okay.
Yep. So it looks like everybody selected cooling.
That's a big factor. That's one of the key things that has to that the function of flush water in braided packing services and mechanical seal services. It's there's two things that flush waters and that barrier that flush water is there for is to keep that product your packing surfaces between your braided packing and your pump sleeves to keep them cool and keep them clean. And that's as long as you understand that concept, that's what that's for. That's half the battle. Let's talk a little bit about compression packing because there may be some people on here that don't really know what packing is. You know, braided packing is still the most common used methodology of sealing fluids in mechanical equipment today. I mean, it's in valves, it's in rotating equipment, even in the nozzles at the gas pump where you pump your gas every day. There's a little set of packing in the gas pump nozzles. So that packing affects your life every day in very small ways. And most people are not even aware of what it is or what it does, but it's a soft material that's put between a moving shaft that's in a confined space and it's compressed and loaded by some loading device. And but it's a very common product. It's in your faucets at home, your outdoor faucets at home. It's just located, in hundreds and hundreds of different places that you just don't realize it every day. Some of the places that packing are used is in pump packing, valve packing, packing for auxiliary equipment, mixers, agitators, in process industries. But it's still the most common method for sealing applications, fluid applications available. And in really a lot of cases, due to its not lack of restrictive radial movements and axial movements like mechanical seals are, packing in a lot of cases is the most reliable solution to sealing a lot of process industry. Basically, this is how it works. We're not going to get into this too deep today, but if you look at the packing is a braided yarn, and that yarn has some sort of lubricants inside of that yarn. You're taking in a confined space, you're taking what we call a packing gland. It's just a follower that's got mechanical fasteners on it that compress that product and actually squeeze and seal against the shaft. And basically, the packing serves two functions. On the OD, the packing is never supposed to leak on the outside diameter, but because it's really a gasket on the outside diameter, but it's supposed to have a little bit of leakage along the shaft. And we'll talk about that and talk about some of the intricacies with that today. But it's just basically just a yarn with lubricants on it that is put in a confined space and compressed. I mean, this could be an expansion joint on piping. It could be numerous places that you go see packing used. Most of what we're going to talk about today is rotating equipment, because rotating equipment is where you see most of the use of flush water. Valves don't really use any flushing. Only rotating equipment in most cases use flush water for extra lubricant. Now, packing has various sources of lubricants. We build the packing with lubricants in it. We have break-in lubricants inside the packing when we actually construct it. But there's two other sources of lubricants that you have to provide for that packing and that to be sealed, that be successful, to have good, reliable packing life. You can use the product being pumped is a lubricating film across the packing, but you can only use the product being pumped if that product is cool and clean. We're going to talk about the cool and clean rule a lot today. The product that you run to lubricate your packing has got to be cool and clean. If you can't provide a cool and clean lubricating source, you have to use an external flush. The external flush provides a clean, cool lubricating source for your packing. So always remember the cool and clean rule. If you remember that when it comes to fluid sealing and lubricating packing surfaces or even mechanical seal surfaces, we're going to have a series in the near future discussing barrier fluids and lubricating mechanical seals from external sources. So just remember, as long as you keep those surfaces cool and clean, you should get good, reliable service out of your products. So let's talk about packing and slurry services. Packing and slurry services require, understand something. The packing is a soft material, and any abrasives, high pressure goes to low pressure. So if you have high pressure in the stuffing box and you have pressure of the device you're trying to seal, was a pump, an agitator, a chest, or a mixer, those slurries are going to want to migrate along the packing set between the shaft and the packing to low pressure, which is atmospheric pressure. So the question is how do you, in those products, once they get embedded in the packing, because they've migrated the shaft along the shaft between the shaft and the packing, those products a lot of times will dewater. Well, when they dewater, they become more abrasive. Well, think about this. Now the package is a soft material. You have abrasive material embedded in it. It becomes a grinding wheel. Now the next question is, what happens to all the metal you grind off that shaft or sleeve? It's also embedded in the packing. So you're enhancing the grinding and cutting effect of the packing by not providing an exterior alternate flush in slurry services. So basically what you're doing, you're injecting, by this illustration, a clean fluid, which in most cases is water, at a higher pressure than what the pumpage is, or the material in a chest or mixer is trying to migrate back along that shaft. And you usually set that pressure at 15 to 20 psi above what that stuffing box pressure is, or above what that vessel pressure is. But also be aware in the real world, in real world processes, if you run the pump against a throttled head, your stuffing box pressure is going to increase. So if you anticipate the operators running the pump against a throttled head, you've got to set your stuffing box pressure above that maximum point where you may end up operating. Can you run packing flushless? This is one of these things that people have been attempting to do for years. The only safe products that you can run flushless are clean products. Boiler feed water, condensate, general plant waters. Those type of applications you can run flushless, and you need no flush water. I can't tell you how many times I've been to plant sites and worked with guys packing equipment, and they put flush water on something that is flush water. So those applications don't need any flush water. I mean, you're sealing a clean product, so you're not required to provide an external lubricant to keep the slurries out. Those products that you're pumping and those applications are more than adequate to do that. And if you run the proper styles of packing in there, a lot of those applications become virtually maintenance free if you'll abide by certain rules and make the right yarn selections, which your fluid sealing supplier can help you with that. And you can technically run those places flushless or waterless. But make no mistake, the places that you try, there's a lot of marketing gimmicks out there. The places you try to run flushless and you get beyond running things in their design parameters, you're going to end up with equipment damage, because there's really no substitute for flush water to keep slurry materials and abrasives from migrating in your packing set other than flush water. There's no way to do that. And when we're going to show you during this process, you don't need lots of flush water. What you want to monitor and maintain is pressures. The pressure you maintain between the lantern ring and this surface within this packing set. This drawing here kind of illustrates a fairly common pump in industry. This drawing is a Gould's 3175 series. And Gould's gives you two flush options. You can put the, as in the top half of this drawing, you can put your flush water in at the bottom, or in the bottom half, you got packing, 2 rings of packing, a lantern ring where you put your flush, and then 3 rings of packing. So that these particular pieces of equipment have 2 options. When you're setting up your flush water, understand it's about containment of clearances. If you look at these 2 illustrations, the lantern rings traditionally are not a close fit item. And when you're talking about product dilution rates and flush water and all sorts of things that come up when you talk about flush water, the top option of this is not the best because you have an excessive amount of clearance and your dilution rates are going to be really high and your water usage is going to be greater. The bottom half of this drawing, where you show 2 rings of packing, a lantern ring, and 3 rings of packing, is your most optimum choice. In any application, you need packing on both sides of the lantern ring. Kind of picture this in your mind. Those of you that are familiar with mechanical seals, the packing technically is a double mechanical seal. You know, we don't use seal faces for sealing inboard and outboard. We're using the braided packing against the sleeve or shaft inboard and outboard to seal, but it's technically the same thing. What you're doing is maintaining a double seal. So the bottom illustration, that if you pack it that way and run your packing with packing behind the lantern ring on the process side, it's going to reduce not only your water usage, but it's going to reduce your dilution rates. And we're going to talk a little bit about dilution rates here in a little bit. Here's a typical pump cutaway for those of y'all to kind of explain some of these drawings. You know, you see your impeller, your lantern ring, the location of all these components. So kind of give everybody a little refresher on all the parts we're talking about so they don't get lost. But this gives you some idea of all the critical pieces that we're using to affect the seal with packing. And we're taking this packing gland with these bolts on the back, and we're actually adjusting that to apply a load to get the packing to adjust to control flush water leakage and process leakage. So what is the purpose of flush water and using braided packing? Like we said, it's to maintain a lubricated, cool, clean running surface between the equipment sleeve and the packing sleeve and the surface. The objective is to keep it cool and clean, and to obtain this clean, cool surface, we must maintain that pressure between 15 and 20 psi above maximum stuffing box pressure. And I'm not so sure we don't have the wrong presentation open. Hold on, if y'all bear with me just a minute, I think we're fixing to come up on some blank slides.
Chuck, okay.
Can I pause this just a moment?
Yeah, we're just going to pause for just a second. Chuck, if you want to close this presentation, and you can open up, I sent you one this morning that said final, so that should be the correct one. I have it pulled up here on my computer too.
Yeah,
you know what, if you want, I can just share my screen.
Share your screen.
Yep.
Because I'm afraid that we got the wrong one open.
Let me, okay. 1 second, guys. I'm so sorry. Please bear with us. Technical difficulties. All right,
Anna
Chuck.
Claire, are you going to share your presentation?
Yeah, so I'm just going to share. I'm just sharing my screen now. And are you able to see it?
Yeah, I'm able to see it.
Great. Okay. I think we were here.
Now keep going. Keep going.
Down or up?
Down. All right, keep going. Let's go one more slide and we'll be there. Okay, we start right here.
Okay, great. Thanks so much. I'm gonna leave this kind of in the view that it's in right now, just so I can make sure I'm controlling it properly
Okay.
instead of going full view. But if I need to go bigger, that might help. Yep. Okay, great. I'm gonna mute myself, but you can just prompt me to change slides.
Am I still live?
Yes. It's no
Okay.
problem. These things happen all the time in live events. So
Oh,
yeah,
okay.
I'm gonna mute myself and then you just prompt me to change the slides.
Okay.
Okay, thanks so much. Thanks everyone for your patience.
Thanks everybody, because we're fixing to come up on some blank slides. But let's talk about this. If you look at this illustration, this is a typical way to set up your packing in the field. Uh, the simple way to do this is to put a ball valve on the inlet, put a discharge ball valve on the discharge side with a pressure gauge. Because remember, we want pressures, we don't want volumes. So how do you control this? The bottom valve where the inlet is where we're going to control your flow rates going to your packing. So what you do is you close the top valve by the pressure gauge and bring your pressure to your desired level. Then the discharge that comes out the discharge side of the top valve, you want that water coming out of there just to be a little trickle of water. So on the bottom side, the bottom valve is what you're going to control the flow rates coming out the end of your discharge line. So if you'll just keep throttling back your flow going to your packing and building pressure with the top valve, that'll set the packing exactly where you want it. Now you cannot do this with anything without putting these valves and these gauges on there, because if you just put gauges up, put valves on it, you really don't know what your pressures are. And if you don't put these parts on there and you just let the water flow straight through, it's not building a pressure. We're trying to build a pressure greater than what the pump pressure is, to keep those slurries and things from migrating back into your packing set and damaging your shaft and sleeves. I mean, this is the lifeblood of getting good service out of braided packing. This is the whole secret to doing it. So it's real important that you control. And can I go to the next slide? No, the next one up. We skipped one. Next one down. There you go. It's very important that you control those flow rates and to get that water usage to a bare minimum, because that's the goal. You know, everybody wants to reduce their water usage. You can buy, these flow meters that go on these applications. The only problem with these little flow meters and these little flow blocks is most people's water quality in their plants are not good enough to run those, because those flow meters are full of little needle valves and pipe scale. You know, a lot of plants are pumping river water that's got, sand, shell pieces, snakes, you name it, you're pumping it out of a river somewhere. And these get all this stuff, this foreign matter gets in your flush systems. If you'll just build it out of piping and valves like this illustration, that allows you to clear any blockages that you get from poor quality water, where all of these little control blocks and these things that you buy to do this with, those are great if you're on industrial water, where you don't have it's basically just one step below municipal water. You can use those. And where those were designed in Finland and Sweden and those places, a lot of those places are using industrial water for flush water. In the United States, in most industries, we're blessed. We have river water and things like that we get water from, and those devices are really not conducive to that. Okay, Anna Claire, go to the next one, please. So packing will leak one of two things. The product you're being pumped, and remember that product needs to be at least cool I mean, at least clean. Cool is a little subjective, but because you can run boiler feed water like this and condensate like this, but it needs to be a clean fluid that ends up passing through the packing, or you have to have an external flush for all slurries. The external leak rate, the recommended external leak rate for braided packing is 10 to 12 drops per minute per inch of shaft size. So, 3-inch shaft, external leakage, 36 drops per minute, somewhere thereabout. And if you'll run good yarns, if you have good installation practices, if you look back some of our previous podcasts, we have lots of discussions about installation practices. Please feel free to view some of that stuff, because some of that stuff covers some of this content too. So it's very important. If you got some other questions, some of those other podcasts, take that, because we do some extensive discussions about fabricating rings and installing rings and all those things. It's important before you get to this point. Okay, Anna Claire, you can go to the next slide. Let's talk about something that is a major controversy, and that's calculating water usage for braided packing. I come from an extensive background in this industry. I've been in this industry total of about 37, 38 years. And in the past, in the 80s, when I started in this industry, one of the big things was converting from mechanical seals to packing. That was one of the big things everybody wanted to do. And I worked for one of the major competitors that was involved in extensive conversions like that. And what we did is we used these drip charts and these flow charts of water flow through piping sizes at certain pressures to determine water usage. And every manufacturer had their own set of drip charts and different kind of charts to calculate ROIs and returns on investment for converting from braided packing to mechanical seals. Lord, we had water usage at that time on some of that stuff that was so extensive that you could pay for a seal in about 3 days based on the water usage. I mean, some of the numbers. In essence, what I want you to do is, when you're making these decisions and making the decisions to invest in packing of mechanical seals based on water usage, I want you to make good decisions. Make good decisions on your own research. A few years ago, I was tasked by the Fluid Sealing Association to write an article concerning this very subject. And of course, when you write articles for a professional organization, all members of that organization, which happen to be a lot of mechanical seal and packing companies, our competitors that got to vet those discussions. And so we went through a long, drawn out process during those discussions to decide what was the true water usage for braided packing. So one thing that we could capture when we were calculating those numbers was we could capture the external leakage. And we know as an industry standard that 10 to 12 drops per shaft inch for external leakage, we know that that was a given number that we knew. It didn't matter how much pressure we had or how much flow we had to the piping we hooked up to that. What mattered is actually what leaked along those two surfaces. The flow of the water out of a line going to that. We can't verify the amount of flow going in this process and out of this process based on just the pipe size, because we really don't know how much flow is going through that pipe. We know what will flow through that size pipe, that size line, but we don't know how much is going through. So, we do know that we knew what we could verify, which was the external leakage out of the packing gland. And that was really the only number that we could verify. The other number, the dilution rates, we really could not verify. That was not a verifiable number because the pressure differentials. On the packing gland side, you have a pressure differential to atmosphere. But on the process side, you only have a pressure differential of 15 to 20 psi. So what's that leakage rate on the internal side? There's where the debate came. So we went through extensive studies and discussions as members of the FSA, and we came to a determination that if you want to calculate the dilution rates as a rule, you take your external leak rate and the dilution rate is roughly 1/2 the external leak rate is a good rule of thumb of what we could expect to see as far as dilution. Well, it kind of turned the mechanical seal part of that business up on its ears, because the water usage numbers that we had been using for years and years and years kind of went out the window. So we also found that the U.S. government uh, has a drip calculator that they developed that's on a website. Anna Claire, can you make that link hot? Can you bring that up?
Sure thing.
That link. If you'll go to this USGS website, this is, as far as an impartial third party means of calculating volumes of water usage, this calculator does it based off drips in a faucet in a house. So this I would consider a good impartial third party source. If you want to do your own studies and do your own ROIs and get your own plants cost per million gallons for water usage, I encourage you to do that this way before you convert from mechanical seals to packing. I mean, back from packing to mechanical seals, because this will kind of give you some true real life numbers as to what the water really costs your facility. And it's really pretty simple. It's not extensive. You can call your operations people, and in most cases, I did a bunch of interviews when I did that article, and I found if you're pumping water out of a river and using it, it's about $400 per million gallons. If you're using industrial water produced by a municipality, it's about $700 per million gallons. So, you can do these calculations and come up with these numbers very simply, very easily, and give you some true insight at exactly what water costs you. The other things you have to get into consideration as far as water usage is, of course, a lot of plants have permitted water usage, and you have to evaluate that. But if you'll go by these basic guidelines and maintain your packing and your and do good installations, do good basic care, maintain your flush waters, plumb your flush water systems up correctly, you'd be surprised how much you can get that cost and that water usage under control with some very, very, very simple in-house basic care procedures. But one of the things I'd like to tell y'all today, our distribution is available to do training for you, and some of these categories. We have people that can do field consulting work for you and discuss some of these issues for you. So if you would just email us, we'd be glad to support you and help you any way we can. Anna Claire, I guess go to the next slide and close this out. If anybody have any questions on this. And so this is the basic steps it takes to maintain your packing and be successful, and get good reliability out of your packing applications. This document's available on our website. You can print that and use that in your shop and use it in your training. It's a very effective, tried, true, proven methodology to get good reliability and get good service out of your braided packing. And you can go to the next slide. Last poll. What's important to water consumption in your facility based on 1 to 5? One the least, 5 being the most important. We're going to take a minute, let y'all vote on this, and we give y'all, Anna Claire, give you the results here in a minute.
Yep, I'm just going to give everybody one more minute or so to get their answers in. 3, 2, 1. Okay.
So what we got, Anna Claire?
Yeah, so it looks like everyone's smack dab in the middle actually with 3.
Okay. Well, that's great. Well, I guess in closing today, we appreciate y'all's time today, and we'd love to assist you in any way we can. Uh, we do have people in the field that can help you and train people for you, and help your training staff in your locations to improve your precision maintenance requirements as far as braided packing. And I guess in closing today, we wish everybody a great week, and
Chuck,
appreciate your time.
before we close, I did have one question I wanted to ask you, and
Okay.
you kind of answered it a bit earlier, but this is just a request to go a little bit more in depth. So earlier you kind of made the comparison or analogy about how packing is technically really like a double mechanical seal. Can you go into that a little bit deeper and like the pros and cons of it, why that might help end users, why that might inhibit end users in the long run, and just kind of dive into that a little bit more before we close out today?
Yeah, and Claire, basically with a double mechanical seal, you have two sets of seal faces, and you're running some barrier, some flush water in between those two seal faces to affect the seal. Packing is very similar to the same way. I mean, you use it with some packing, a lantern ring, and some packing. The two packing surfaces are technically just a seal face that's created by the braided packing running against the pump sleeve instead of two faces running together. If you understand that concept, you understand that it is very much like a mechanical seal. You get a better grasp on what the dilution rates are and what the leakage rates are, and all that stuff is quantifiable. In the past, it's been somewhat, even with mechanical seals, it's somewhat uh, a wild guess. But one of the benefits of using packing over mechanical seal is if you have an inboard sealing surface failure that's catastrophic. Catastrophic sealing surface failures with braided packing don't really happen. But with the mechanical seals, you can have face breakages and springs that fail and all sorts of different things that fail. There's several different modes of failure with the mechanical seals that don't exist with packing. Packing's pretty basic, pretty simple, and pretty straightforward. But the problem with a mechanical seal, if you have an internal seal face failure, you get huge amounts of dilution and huge amounts of water usage. What happens on the inside, for those of you that use mechanical seals, is the same catastrophic failure mode that you see externally when you have a mechanical seal that fails and it just pours water or pours product. That same failure mode happens internally, but you don't see it. There's where the problem comes. And you have to be able to keep up and monitor that and keep up and make sure you don't have those internal failures, and that those failures don't run for weeks and months and weeks and months and months. The problem with running in some applications a mechanical seal versus braided packing is that those catastrophic failures may not be monitored and kept up with on the internal side with a mechanical seal. And anything you save by converting from a packing to mechanical seal, you may spend thousands of times over, because the purpose of converting from packing to mechanical seal in the beginning was the water usage. And so if you're dumping 100 times more fluid in your process than what packing ever would, anything that you would ever saved is gone for years. I mean, you're just like putting water straight in the process. And that's some of the things that you've got to consider, when you convert from packing to mechanical seals is, do you have the safeguards in place to make sure that if you do have a problem, do you have the safeguards in place to follow up and make sure those problems don't run for extended lengths of time? And so basically the benefits of is of packing over mechanical seals, because they're basically both running a double mode. If you run a double seal, you run packing with packing on both sides, you're getting the same effect. And so, some of the basic care has to be more active with a mechanical seal than it does with packing.
Awesome. Thank you, Chuck. And thank you everyone for attending. Here is Chuck's information. You can find him on LinkedIn, or you can shoot him a call to the SEPCO office in Alabaster. Also, be on the lookout for next month's webinar, where it's going to be part 2 of this series, where we are going to dive more heavily into the mechanical seal side of this topic. And Chuck will be back with us for that conversation. So thank you everyone. Thank you, Chuck, for your time. And we look forward to working with y'all again on these webinars. We hope to see you next month. Thank you so much.
Thanks, everybody. Have a good week.
Yeah, bye everyone.